Lesson 45, complex fractions. A fraction is a complex fraction if its numerator or denominator, or both, contains one or more fractions. This rule in orange, a divided by b divided by a fraction c divided by d, is equivalent to saying that you have the first fraction, a divided by b, multiplied by the reciprocal of the denominator, which is d over c, which top times top creates AD and bottom times bottom creates BC. Folks, that rule is the biggest mathematical rule that we're going to use today in the example, so my advice is have that written down. So for example 1, we're going to simplify. We have the fraction a to the negative first minus x to the negative first divided by a to the negative second minus x to the negative second. Now what you got to know is that these are binomials, right? We're dealing with binomials because we have that plus or minus in there. So let's write what we have, right? Negative exponents means we drop it down low. So we have 1 over a minus 1 over x. Now we're dividing that fraction by the fraction 1 over a squared minus 1 over x squared. Okay, so now off to the side, I got to find a common denominator of these two fractions. So if I have 1 over a minus 1 over x, now they don't have anything in common from what I can see, so I'm going to have to multiply this by the opposite's denominator. So I have a over a multiplying my second fraction and x over x multiplying my first fraction. So when I do that, again, it's top times top over bottom times bottom. So I get x minus a over xa. Now that's my first common denominator. Now we got to find the second fraction's common denominator. So I have 1 over a squared minus 1 over x squared. Yikes, again, I don't have anything in common. So I have to multiply by the opposite's denominator, x squared over x squared, and a squared over a squared. From here, I multiply top times top and bottom times bottom. So I get x squared minus a squared over x squared a squared. Folks, these now get replaced. I'm replacing the numerator's fraction with x minus a over xa, and I'm dividing that with the new denominator's common fraction, which is x squared minus a squared over x squared a squared. Ugh, yikes, right? Now, if we think back in orange, I told you at the beginning of this lesson, you might want to write something down. That's this common theory that if I have two fractions like this, I can multiply the very top one with the very bottom one. So I now have this factor of x minus a times x squared a squared. And I'm dividing that with the middle two things. So I have x times a, and I'm multiplying that with this difference of squares, x squared minus a squared. So if I'm thinking ahead, I'm going to factor that difference of squares, and I'm going to see, okay, now are there any common factors I can cancel? Well, I see that x minus a cancels with x minus a, and I see that x would cancel with x squared, and I see a would cancel the squared. So then I'm left with my final answer. I have xa divided by x plus a. Now this is the first method in solving this example. There's another method for solving this, so I'm going to show you that method. That method is going to utilize the common denominator fact on the right. So if you look at the right, remember these are common denominators, so I'm going to utilize this knowledge for the next slide. Okay, going to this next slide, so showing method 2. Method 2 says you can find your common denominator of both numerator and denominator, and if we did, we remember that we have those beautiful fractions, right? We have the x minus a over xa, that's the common of the numerator, and the common of the denominator was x squared minus a squared over x squared a squared. Now, if you think about this, the largest of the two common denominators, meaning if I said, okay, now of these two fractions, what's the common denominator? Do you agree you would announce that it's going to be this is my common denominator of the two fractions? If you agree with that, then think about this. You could rewrite what you were given, 1 over a minus 1 over x. Now we're dividing that with 1 over a squared minus 1 over x squared. Now, if I multiply just the top by a squared x squared, also known as x squared a squared, and I multiply just the denominator by a squared x squared, then what happens is my division of a on the first term is going to make it so that I cancel some stuff out. And this is where it gets a little interesting. I now have a x squared minus a squared x divided by, now think of this denominator, right? I'm canceling out the a squared with the a squared, so I'm left with just x squared minus a squared. Wow, so I just cleared my fraction. Okay, so now what you have to do is you have to find, okay, what's in common on the numerator? Well, on the numerator, I have this common term of a and x that I can factor out. If I factor out ax of the first term, I'm left with just x. And if I factor out ax of the second term, I'm left with just a. Now, if I divide that with what I was given, which is that difference of squares, x minus a times x plus a. Okay, now cancel your common factor. So my common factor is x minus a over x minus a. And folks, final answer is the same as the previous one, ax over x plus a. Okay, so that's method 1 and method 2. You pick your method for which one you believe is your best. I'm going to head on to example 2. Example 2 says we're going to simplify this fraction, 5 plus 1 over m minus 6 over m squared, divided by 2m minus m squared. So off to the side, I need to find a common denominator. Now, if I look at the numerator and I look at the denominator, both of them have a fraction of m and m squared. So I'm going to write off to the side 5 plus 1 over m minus 6 over m squared. And if I think about the common denominator of 1, m, and m squared, it would be m squared. So I'm going to multiply everything by m squared. So I have 5m squared plus, 1 over m times m squared is m. And then this would be minus 6. Now we all have this over this beautiful fraction, m squared, because I multiplied everything by m squared divided by m squared, right? I was trying to get that common denominator. So from here, I go, okay, now let's look at the bottom. The bottom fraction has, so this is my common denominator of the numerator. Right, that's my common fraction of the numerator. And my denominator has 2 over m minus 2 over m squared. So again, getting a common denominator of these two denominators is going to be m squared. Thinking about that, my first fraction has to get multiplied with m over m. So I have 2m minus 2 over m squared. Now again, this is my fraction of the common denominator. So we have replacements. So my replacement's going to be 5m squared plus m minus 6, all divided by m squared. Now that's my first fraction. Dividing that with my second fraction, 2m minus 2 over m squared. Now again, I told you at the beginning of this lesson, if you wrote this fraction down, a over b divided by c over d, you'll always know how to do this because remember, a and d will cancel. So if you think about a and d will cancel, right? Well, a and d will multiply, sorry. Well, if a and d multiply, doesn't that mean that b and d cancel? Now let's write this off to the side real quick so we can see this. Remember, it's ad over bc. Do you agree with that fraction that I could cancel out d with b if I ever saw that? If you agree with that, then think about this. Here is b, and here is d. So guess what? They cancel. So I'm left with 5m squared plus m minus 6, all divided by 2m minus 1. Okay, well now that means factor your numerator. So what multiplies to negative 30 that adds to positive 1? Well, it's going to be 6 and negative 5. So we have 5m times something of m. Now we need this to say negative 5, but a positive 6. So I'm pretty sure that'd be negative 1 and positive 6. Now let's check it. 5m times m is 5m squared. Negative 5m plus 6m makes that positive m, and then negative 6. Fantastic. We have it factored properly. Now we're dividing this by 2, m minus 1, and guess what? M minus 1's cancel, and folks, we're left with 5m plus 6, all divided by 2. And that's your final answer. Okay, now we're going to use that idea with this next problem. So here's the example 3. We're going to simplify x over 15 divided by x minus 2. Divide that numerator by x minus 20 over x minus 1. So again, off to the side, Weissmuller's going to put her the numerator, and find the common denominator of said fraction. So we have x minus 15 over x minus 2. Now remember, this has a denominator of 1. So I need a common denominator of x minus 2. So that means that my common denominator is x minus 2. And I need to multiply x times x minus 2. So that's going to be x squared minus 2x. And then minus 15, because that comes over, that is the denominator. This is the replacement of my numerator. Okay? Then I do the next one. Well, the next one says I have x minus 20 over x minus 1. Now again, remember this is over a 1. X is divided by 1, so common denominator would mean we're dealing with x minus 1 as our common. Now I have this negative 20 that stays as it is, but I have to multiply x times x minus 1. So I get x squared minus x minus 20, all divided by x minus 1. So now let's replace our what we know, right? We have x squared minus 2x minus 15 divided by x minus 2, all divided by x squared minus x minus 20 divided by x minus 1. So do you agree we would now have to factor both the numerators of each fraction on numerator and denominator? Okay, so let's factor the numerator. What multiplies to negative 15 that adds to negative 2? Well, that's going to be x minus 5 and x plus 3. Now I'm dividing that with x minus 2. And then that fraction's being divided by, well, let's factor the numerator of the denominator. Well, what multiplies to negative 20 that adds to negative 1? That'd be x minus 5 times x plus 4 divided by x minus 1. Okay, so then here comes back to that a over b divided by c over d, and that is equivalent to saying AD over BC. So what I want you to think about is, I notice there's a numerator, A has something in common with row C. Well, do you agree that I'm allowed to cancel yet again this A with that C if I see a factor? So I see that x minus 5 and x minus 5 have a common factor. So guess what? Cancel them. So we should be left with, if you see what I'm saying, we are left with this beautiful thing of x. Now do your AD over BC. So we have this fraction of x minus 1, that's d, times a, which is x plus 3. And I'm dividing that by b and c. Well, b was x minus 2, and c, x plus 4. Now, do you see any common multiples? I do not. So, folks, that is the final answer. Good luck on the homework, folks.